Math 7, Unit 1, Lesson 7, Part 2. Adding rational numbers, vocabulary, and algorithms. Okay, in today's lesson, we will be adding and subtracting rational numbers and express answers as decimals. We're going to add and subtract rational numbers and express the answers as fractions. Work fluently with subtraction by using addition of rational numbers using the additive inverse property. That actually kind of comes into the next lesson. I can explain various models of addition of rational numbers. I can model and solve situation problems and interpret the solutions in context. When adding rational numbers in decimal form, it is of vital importance that you line up place values. The easiest way to visualize lining up place values is to line up the decimal point. You follow the same rules for addition and subtraction of rational numbers that applies to integers. See page 5 in your notes. Example, evaluate negative 4.5867 plus negative 51.903. First, you should notice that according to the Who Wins addition model, both numbers are negative, so we're going to add their magnitude, their size, and report the resulting sum as negative. So we stack it and add them together, and we line up the decimal, we get negative 56.4897. Okay, second example. Evaluate 14.6 plus negative 19.5. First, notice according to the Who Wins model of addition, the numbers do not have the same sign, therefore subtraction is used. Negative 19.5 has a greater magnitude, so we will subtract 14.6 from 19.5 and report the resulting difference as negative. Next, subtract using the standard algorithm and regrouping. Last, you report your answer as negative 4.9. So the decimal's already lined up here. We have to do the regrouping or borrowing, and we get negative 4.9. Adding and subtracting fractions and decimals, the vocabulary. Numerator, the top number in a fraction, it tells how many pieces. Denominator, the bottom number in a fraction, it tells how big the pieces are. Larger denominators create smaller pieces. Okay, for example, 2/5. The numerator tells you there are 2 pieces. The denominator tells you that the unit is cut into 5 pieces. So the top tells you how many pieces you have. The bottom tells you how many pieces the unit is cut into. And there's an example over here drawn of 2 out of 5. Mixed number. A rational number expressed as a whole number plus a fraction smaller than 1. For example, 3 and 1/9 means 3 plus 1/9. That's what mixed numbers mean. Common fraction. A rational number expressed as a quotient of 2 numbers, sometimes called an improper fraction when the magnitude is greater than 1. So these are common fractions: 5/9, 9/5. 9/5 is also an improper fraction. Negative 1,435 thirds is also a common fraction. It's just a number divided by another number. Okay, let's get into fractions. When adding rational numbers in fraction form, it is vital that the denominators are the same. This is for the same reason that you line up place value for decimal addition. Denominator is like a place value. That's an important thing to understand. Denominator is like place value. That doesn't have to be a power of 10. Like 0.01 is actually 100th. That's actually written wrong. That's actually 100th. And 0.001 is 1,000th. Generally, getting the common denominator is important for the exact same reason lining up place values is for adding decimals. You want to add tenths to tenths and hundredths to hundredths and tens to tens. That's why you line up your decimals. In fractions, you need a common denominator so that you're adding up common sizes of pieces. So for our example, we're going to do 5/12 plus negative 9/16. First, a common denominator is needed. Compare the multiples of 12 and 16 in order to find a common multiple that can be used as a common denominator. So the multiples of 12, I've listed here: 12, 24, 36, 48, etc. The multiples of 16, 16, 32, 48, 64, etc. The smallest number that they have in common is 48. We also could use 96 or 144. Usually the least common multiple is used. However, any common multiple may be used. So we change it Next, using the common denominator, which we chose to be 48, we replace each fraction with an equivalent fraction. Make the substitutions. 5/12 is going to become 20/48, multiplying top and bottom by 4. So 5 times 4, 12 times 4. And negative 9/16 becomes negative 27/48. That's times top and bottom by 3. 16 times 3 is 48. Negative 9 times 3 is negative 27. Then, using the who wins model of addition, the signs are different, so we subtract. Compare the magnitude of the numerators. When the denominators are the same, you can just compare the numerators. Because negative 27 over 28 has a larger magnitude, we subtract 20/48 from 27/48 and report the answer as negative. Okay, so negative 27 plus 20 is negative 7. Good. And the common denominator stays the common denominator. Last, add the numerators and reduce. Because 7 over 48 will not reduce further, we report the answer as negative 7/48. When adding rational numbers in mixed forms, represent both rational numbers in the same form, either both fractions or both decimals. And you'll get the opportunity to practice that in the assignment. Okay, this is the end of this video. Stay tuned to the next video.